geobyte.
Then let us take the another important problem. It is asking like this. A thin flat circular disc of radius 4.5 centimeters is placed gently over the surface of water. Here radius are given 4.5 centimeters are equal to 4.5 divided by 100 meters, right? Because 1 meter equal to 100 centimeters. If surface tension of the water is surface tension generally marked with T 0.07 Newton per meter, then the excess force required to take it away from the surface is. What is the excess force required to take it away from the surface? That means how much external force is required for the water to go away from the surface of the thin flat circular disc. For that, let's look at the thin flat circular disc. Let assume some no, it is placed in the what liquid or like water. This is the water because the water surface tension is given. Now the surface tension is acting like this. This is how the surface tension is developed. Okay, surface tension is developed. Then, as you know, surface tension. Listen carefully. Surface tension T equal to surface force per right length, unit length. Here length means circumferential length. Therefore force equal to surface tension multiplied by circumferential length, that is 2 pi r. It is equal to surface tension 0.07 into 2 into pi value 22 by 7. Look at the r value 4.5 divided by 100, You simplify this value for getting 19.8 into 10 power minus 3 Newton meter. Tension force, no? Force is Newton only. Newton only. That is the answer. But that option is not available. That's why it can be written as 19.8 millinewtons. Millinewtons. Option D is correct. Okay. 10 power minus 3 10 power minus 3 newtons equal to 10 power minus 3 newtons equal to, right, 1 millinewtons. That's why it is taken 19.8 millinewtons. Option D is absolutely correct. Are you following clearly? Yes. Similarly, let us take the another important problem. Look at this problem asking like this. The viscous drag acting on a metal sphere of diameter 1 mm, diameter of metal sphere d equal to 1 millimeter, falling through a fluid of viscosity zero point 0.8, viscosity eta equal to zero point 0.8 Pascal second, with a velocity v equal to 2 meter per second is equal to. We are asked to discuss viscous force or viscous drag for the metal sphere. Look at the metal sphere first. This is the metal sphere, right? Some viscous liquid is there surrounding to the sphere. Then what is the drag force or developed viscous drag developed between the liquid and that metal sphere. As you know, viscous force viscous force F suffix V is equal to 6 into pi into viscosity, coefficient of viscosity into R into V. R into V. It is equal to 6 into pi. I can write 22 by 7. I can write 22 by 7. Viscosity is given zero point 0.8. Now, this is the diameter. Radius R equal to D by 2. D is equal to 1 by 2 mm. But it should be converted to meters. 1 by 2 into 10 power minus 3 meters. 1 by 2 into 10 power minus 3 meters multiplied by the velocity. Multiply velocity 2. Simplify this value for getting around 15 into 10 power minus 3. Since it is the force which is in newtons. 15 into 10 power minus 3 newtons. Look at the option C. Option C is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. The amount of energy required to form a soap bubble of radius 2 centimeters from a soap solution is nearly given the radius of the soap bubble are equal to 2 centimeters, that is equal to 2 by 100 meters, because 1 meter equal to 100 centimeters. And look at the surface tension for the soap solution. Surface tension T equal to 0.03 Newton per meter. Okay. Dear friends, remember, since it is given for soap bubble, remember soap bubble is maintaining two free surfaces. It is like this. Look at the diagram. The soap bubble is maintaining two free surfaces which are in contact with the air. One is inside the bubble, other one is outside the bubble. Let me write it clearly. This is the outside layer, right? Free surface. Outside free surface. And look at the inside free surface. This is the inside free surface. Inside free surface. Okay. Now, anyhow, as you know, surface tension, let me write it clearly. Surface tension T equal to, you can define the surface tension either in terms of surface force per unit length or surface energy per unit area. Surface energy, surface energy per unit area, per unit area. Therefore, surface energy equal to surface tension T into area. But since it is having the two layers multiplied with 2, because it is having the two free surfaces, it is equal to 2 into T, you know, A equal to 4 pi r square, 4 pi r square. It is equal to 4 into pi value is 3.14, I can write, or 22 by 7. 3.14, 4 into 3.14 into radius 2 into 10 power minus 2 whole square. Okay. So surface tension value given 0.03, 0.03 into area. Look at the area, 4 into 3.14 into 2 into 10 power minus 2, 2 into 10 power minus 2 whole square, because 4 pi r square. You simplify this value for getting approximately 3.01 into 10 power minus 4. Since it is for energy, SI unit of energy is joule. 3.01 into 10 power minus 4 joules. Therefore, look at the option D. Option D is absolutely correct. Understood clearly? Yes. Then let us take the another important problem. It is asking like this. The Venturi meter works on, dear friends, remember, Venturi meter, orifice meter are working on the Bernoulli equation or Bernoulli principle. Look at the options. The principle of perpendicular axis, not at all. Hygiene's principle, no. Bernoulli's principle, absolutely correct. Venturi meter, right, is working based on the Bernoulli's principle. Similarly, theory question. Similarly, look at the another important question. It is asking like this. two copper vessels A and B have same base, same base area, but of different shapes. Okay, there are two copper vessels A and B are maintaining the same base area but different geometric shapes. A takes twice the volume of the water as that of B. That means volume of the A equal to 2 times the volume of the B to fill up to a particular common height. Particular common height means height of the A equal to height of the B. Okay. Then the correct statement among the following is, look at the option A. Pressure on the base area of the vessels A and B is same. Absolutely correct. As you know, pressure P equal to what? Pressure P equal to rho into G into H. Rho remains constant, G constant, HA equal to HB. Then PA equal to what? PA equal to rho A into G into HA, and PB equal to rho B into G into HB. Remember, rho A equal to rho B. Therefore, since HA equal to HB, I can say that PA equal to PB. Option A is absolutely correct. Understood? Look at the other options. Pressure on the base area of the vessel A and B not the same. No, not correct. Both vessels A and B weigh the same. No, both vessels are not weighing the same because weight equal to what? Weight of vessel. Weight of the vessel equal to mass of the vessel into G. You know, density rho equal to mass by volume. From this, mass equal to density multiplied by volume. Volume. It is equal to density multiplied by volume multiplied by G. Right? No, the weight of the A equal to what? Rho volume of the A into G. Weight of the B equal to density remains same into volume of the B into gravity constant. Right? You know, the weight is completely depending on the volume. Look at the volume given. Volume of the A is twice the volume of the B. Volume of the A is twice the volume of the B. Since volume of the vessel A is equal to 2 times the volume of the B, I can say that weight of the vessel A equal to 2 times the weight of the vessel B. Right? Therefore, weights need not be same. It is given as both vessels A and B have same weight. Not correct. Vessel B weight is twice that of A. No. Vessel A weight is 2 times the vessel B. D also not correct. Only option A is correct. Are you following clearly? Yes.
Geobyte.